Hello, everybody. With Paul, we present research about forensic investigation and advanced threat. The goal of this talk is present a tool named Fast Collector. We have developed a first release named Fast Responder, but we killed Fast Responder and we make Fast Responder 2.0 named Fast Collector. So we present the new soft and with different case with Paul.
Yeah. So my name is Paul. I work with Sebastien on the Sequoia cert. So basically, I'm a reverser and malware analyst. I'm located in Luxembourg and Paris, and I'm one of the co-organizers of BotConf, a conference dedicated to malware, botnet, and stuff like that. This year it will be in Paris at the beginning of December.
So, Sebastien, in Sequoia, I'm an incident handler and a digital forensic expert, and I love Python. I develop many tools on Python, and like Paul, I'm a co-organizer of BotConf, and I'm a member of OnNet project chapter France. It's a big project about fighting malwares and criminals on internet. So, what's Fast Collector? When you start the development 2 years ago, there are different tools to make a live collect on forensics, named cross response by CrowdStrike, and but the problem of cross response is not open source, so it's difficult to modify the different decoding artifacts on the Windows computer. So we decided to develop from scratch a new collector based in Python, and the goal is to execute all Windows version with the same binaries. So Python is a good solution, and a strong constraint is the collector is a standalone, because when you make forensics, you don't have to install different tools on compromised computers, because you kill the evidence in the computer. So a strong constraint is the binaries is standalone without installation, plugin, or models, or library, just executing standalone. And the second constraint is configurable, because when you make incident response, you don't know if the threat it compromises the computer, so you don't know which keys registry was modified or file dropped on the computer, or DLL jacking. So the goal is to make a software very modular and configurable. And we support Windows XP until 8.1. And so we release today the source code in the new repository on Fast Collector.
Yeah, for the moment the directory is private, and we will switch on public after the talk.
So the tools works two ways. Just double click on the exe directly, and it executed and it collect different artifacts, or directly in CLE with the CMD. And here, the example is just export the MFT and make a CSV about the MFT. So when you make forensics on a computer, on live computer, the goal is to collect different artifacts. An artifact is a piece of data on Windows, like registry key, so like name pipe, like logs, like prefetch. So the first step of the development is to collect all artifact in the Sans Institute 408. The Sans Institute made a methodology to collect different artifacts to detect a compromised computer. So we have based the code on this methodology, and we add different artifacts more interesting, like MFT, like RAM, like file, collect different file on particular directory, like app data, temp, and all artifact collect. It can be configurable by a file config. So it's the list of different artifacts we collect. So it's a piece of code of the configuration file. So we define a path, a MIM filter. The MIM filter is to catch the different file on the computer, and MIME-zip, because all result is stored in the CSV files at the end of the execution. But if you want to catch different file, you configure MIME-zip with different. It's a MIME type. And there is a grammar to collect with if the different filters is or and different properties like size min or size max, extension, and if you make a zip or not. We can filter on the certificate binaries, embedded or not. You can ask to catalog Windows to check the issuer and the subscriber of the certificate, or directly on the the PE. And we have different rules Yara to collect directly on the disk. We decode many registry key like startup, MRU, recent docs. We decode prefetch. We decode MFT, MBR, and all result is stored for the moment in the CSV file or different files log. Yeah, I say file capture description and signature filter.
Yeah, just we support Yara too. I
Yeah.
don't know if
Yeah.
you mentioned that.
Yeah.
So you can create Yara rule, and the collector will check every file located in the path, and will check if it match or not your Yara rules. So what is the purpose of this talk is not only to mention that we developed a tool and we will release it extra. My purpose is more to explain to you how I use it on a real case. So he really quickly explained what we did. And now I would like to speak about several topics. Some cases were really mediatic, some other not so mediatic, and explain how works the malware, basically, and how we use Fastir to detect it on incident. So just for information, we decided to choose several kind of malware such as rootkit, bootkit, and more classic remote administration tool. And I'm going to speak quickly, and I will not mention everything, so I decided to publish a blog post on our blog at this URL. It's not online yet, I will do that after the talk. And you will be able to download a PDF with a whole explanation and more detail, extra. So, I think I've got 5 or 6 case studies. Just if you start too boring after 2, I'm sorry. So, the first one I decided to explain is Ouroboros, Sturla, Snake. It depends of AV vendors. So, what is this specific malware for people that who don't work in this industry? Is a rootkit. It was publicly mentioned at the beginning of last year, but it was used more or less since 2008, maybe a little bit early. He probably state-sponsored by, always probably, Russian government. And some specificity is it used virtual file system. So instead of storing file on the infected machine, on the C drive or whatever, he mapped in memory a file system, a kind of D, but without any letters. And he wrote in this directory every temporary file, every file stolen, everything, additional tools and everything, he stored in memory in this NTFS file system. So it's really useful for the attackers because it's not easy to identify it. And the attackers can use the Windows API because it's a real file system, even if you don't see it. So it's, for me, one of the particularities. The other one is, as every rootkit, he hides itself. So you cannot see the .sys file, the driver itself, the malware itself. With the Explorer, MS-DOS, or what you want, you are not able to see it first. And he did exactly the same thing with the registry. So the registry used to load the .sys file cannot be read with regedit or these tools. So it's more or less the two really specific stuff that concern us for today. So as I explained, the complicated part on this kind of investigation is you cannot trust the system because you cannot see the file. So basically, one of the approaches to make an offline investigation. You switch on off the machine, you take the hard drive, and you make the investigation on a more or less clean desktop. But for specific reason, for example, imagine it's an Active Directory or the Exchange server that is compromised, you cannot switch off the Exchange and say you don't have any email during my investigation. So we have to make a live investigation and forensic analysis. The first thing is when you simply execute the collector, you have several CSV files, as Sebastien mentioned to you, and 2 files are pretty interesting in this case, is the file catcher.csv. So this file contains all the file that match the rules he explained just before, and a zip file. So if you look at the zip file, what are the files inside is every PE file, or Word, or this kind of sensitive file. And we have a filter to avoid collecting Microsoft file, for example. So typically, on my machine, the unzip.l output is all the content of the zip file we collected, because we exclude Microsoft file, extra. And in this case, I've got 3 files, the 3 last one. It's legitimate Microsoft file, but they forget to sign it. So too bad, we collect it. But the first one is the most interesting. The first thing is it's a .sys file, so it's a driver, theoretically. And the path is really uncommon for driver. Typically, drivers are located in driver 32 directory and not in $NT uninstall, extra. And in this case, if you use the Explorer to browse and see the content, you will not able to see the NT uninstall blah 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 directory. So it's the driver used by the attackers to compromise the machine. So it's, in this case, it's really easy to identify it because we only collect 4 files. On the bottom of the slide, you have the output of the CSV file. So you've got the host name of the machine, basically, and you have the path. You can see the fdisk.sys. You have the SHA-256, and after you've got the VT virus total link. So basically, if you check the link and you don't have any results on VT, you have some chance it's not really normal, especially for a driver installed on Windows system. So these first 2 files allow me to identify where is the malware, where is the driver, etc. But I can use the startup.csv file. So as you can imagine, it's a file that contains persistence mechanism. In this case, you can see that I've got a service called Ultra, and with my fdisk.sys path. So even if the system is not able to read it with the Windows API, we are able to get it. Because it's really here, it's simply hide. So, just for information, because I saw a lot of stupid article about Snake, Turla, etc. Turla, the name is linked to Ultra. You mix every letter and you have Turla. Yeah, just for information. So, another thing, if you read paper from an antivirus company, etc., often company mention he creates this directory, he has this kind of network communication, and on this specific case, AV company mentioned that malware use name pipe to internal communication, and the name pipe are named in the article. It's ISAP, HTTP2, etc. So thanks to the collector, we have a file in output named namepipe.csv, and if you look on it, you have every name pipe that are open on your system. And I don't have only 4, I've got more, but on this file I'm able to detect easily this indicator of compromise. So I found the binary, the persistence mechanism, and the name pipe. Another thing is the prefetch. I think you can explain what is prefetch.
So prefetch, it's a mechanism of Windows to charge quickly an executable, and is stored on a folder C Windows prefetch, different files terminates by point pref, and it's a binary file, and you have different information. The program the date of the program execution, the name count of the count of the execution, and the path of the exe, and all DLL was loaded by the exe. So it's very, very, very useful to make an investigation on a compromised computers, because you have this information.
Yeah. So on this specific case, we can, if you look at the prefetch, or the CSV output is directly interpreted. You don't have a binary stuff. It's text plain. Exactly. So you can find 3 specific stuff. It's in fact the usage of the virtual file system mapped in memory. So raw disk 1 is the name of this virtual file system, and keylog is for kernel log. So the rootkit store is log on this file. You've got $mft, so it's a partition table of the virtual file system, because as it's a real file system, it uses real mechanisms such as MFT. And the Q file is internal file used by the rootkit to store several stuff. It's not really important.
And the MFT named master file table. It's the whole history on the NTFS file system on Windows, or different modification creation on by file on the system is recorded in MFT. So it's very, very, very interesting stuff to have a timeline of the hard drive to know how to pass on the computer.
Yeah. So it was the first thing, the first case studies I decided to mention, and I think it's one of the most interesting because in this case you are able to make forensics collect on file you are not able to see. So the second case I chose is Comrade. So it's something more common. It's a remote administration tool in userland, but it's more than probably developed by the same authors. I say that because some part of code I simply copy-paste. So it's not an interpretation, it's really copy-paste. And something really specific on this sample is the fact that they use a really, really uncommon persistent mechanism. So, for example, if you use autoruns from sysinternals to list all your process started at the boot, you cannot see it. It's not list. In fact, how they work, on Windows you have COM object, so typically it's a connector to manipulate a Microsoft object. For example, you have COM object to use the browsers. Instead of developing your own browsers, you can say, I want to use Internet Explorer thanks to this COM object. And on Microsoft, more or less everything is COM object. For example, you can manipulate the browser, you can manipulate Outlook, you can manipulate everything, every Microsoft product, thanks to COM object. A COM object is simply a number, a huge number. And how the attackers did the persistence, they create a COM object with exactly the same ID than a legitimate COM object. And when an application, a legitimate application, want to call this theoretically good COM object, they use the ID, execute the bad one does bad things, and after execute the legitimate one. So in this case, you don't really have autorun. It's simply I hijack a legitimate Microsoft mechanism to make bad thing. So in this case, I use the file catcher. I've got a zip file, and in this case, I've got the free last file is always a free file not signed by Microsoft, false positive. And the two first one are .tlb file, not so common, and it's two P files. It's two executable or library. So I can guess that one of these two files are the malware itself. But as I said, it's a really, really uncommon persistent mechanism. So in this case, our collector is not able to detect it. In the future, we will add this feature, but today we are not able to detect this specific registry key. The number of the COM object is huge stuff in the middle. So even if we don't have the persistent, we have two weird files on the system. Another thing that we collect automatically is process underscore dll.csv. So it's every library loaded on every process on your system. So typically in this case, I've got explorer.exe, and this explorer.exe, inside of the process, I've got the two TLB file. So basically, they hijack a COM object. This COM object is used by Explorer. So how Microsoft works, once Explorer wants to use this specific COM object, he loads the library that is behind this COM object, and in my case, it's my two TLB file.
And the directory where the DLL was loaded is strange because you have document setting, demo, application data, Microsoft. So it's very a good software don't have the library in this directory. So it's
something not
it's
normal,
suspicious.
not common.
It's just on looking, it's suspicious.
Typically, except on several cases, if you got library inside of your document in setting, it's not. It could be, depends on how you install it. See, if you have standalone application, this kind of stuff, it can be everywhere, but theoretically, it's not so common. So the third case I decided to choose is simply because it's probably the French Dutch, donc I decided to mention it, is Babar, the well-known. So for non-French people, it's a common remote administration tool in userland, nothing really exotic. But for French people, it's interesting because it's more than probably, because they more or less say they developed it, but it's probably developed by the French intelligence. So,
is there anybody here that would like to refute that?
They're shy. So, as the previous case, I simply get the startups.csv. So every file started with this common mechanism. And in this case, I've got this weird stuff. So I've got a DLL run at boot with a reg svr executable. And the DLL is in document settings. And obviously, the DLL is start during the boot, and I've got a process reg svr with in argument the .dll file. So as you can see, in this case, developers doesn't really care about hiding stuff. I've got a process, I can see it. Even with Task Manager, you are able to see the process.
Yeah, to collect the execution process, we used WMI, Windows Management Instrumentation, and we list the different process with a WQL query directly on the COM object, and we have all process on execution, and to list different DLL, we use the PS utils, and you have the different DLL, the different handle on exit directly.
So another thing is exactly as previously, I can use our process underscore DLL CSV to list every loaded library inside of binary. And I can see in this case that on explorer.exe, on vboxtray.exe, on ctfmon.exe, the perf underscore blah blah DLL is loaded. So basically this malware is loaded on more or less every process. It's simply a free example, but I've got more process with the DLL loaded. So another case study is Casper. So it's more or less a brother of Babar. It's developed by the same people. I say that because I've got exactly the same thing. They copy paste code, so maybe it's not the same developer, but it's the same repo. And it's it's a userland remote. It's a classic userland remote administration tool. So in this case, the developer tried to be a little bit more clever, and they use a persistent mechanism that looks like a real one. So in this case, it's VBox Audio Interface Device Manager, and on my machine, on my virtual machine, I use VirtualBox. And if I read quickly, I can miss the sample because it's located in a legitimate directory. It's on program file, not on document setting, extra. So if I read too quickly, I can easily miss it because it looks like something legit. So we have the file catcher that makes zip of executable file located in several paths, but we don't parse program file by default. because we are able to filter with signature, Microsoft signature. But if we do that on the program file directory, the zip will be gigabyte of data because you have too many applications, not signed by Oracle, Adobe, I don't know. So by default, we don't scan this directory. As Sebastien explained, you can have a profile and you can modify it and scan the drive, the C drive if you want.
Yeah, if you want collect the exe in programs file, it's possible. But like Paul said, it's too edge to analyze after. So we have different mechanism on Windows, like persistence, like DLL loading. It's clever to collect this data to analyze than exe in program files. So it's just a paradigm, an hypothesis of collection.
Yeah, and we don't mention that because we don't really use it, but it's implemented. If you wish, you can configure the collector to dump the physical drive. So you can get your whole C drive collected. So if you have space, you can do that anytime. You can do that. Yeah. Another case, really funky, is Polix. It was not really famous, but it's for me the first case of malware without any file. It doesn't use any file to be installed, loaded, and to be executed. So everything is in a registry. So in fact, he used a trick to execute from the registry, decrypt content from registry, and execute this decrypted content in memory. So you don't have any file, and he doesn't need any file. And he's persistent, because we already saw malware without any file, but he's executed, typically collect information on the machine, send the information to the bad guy, and it stopped. So in this case, you don't really need file. But for persistent mechanism, usually you need file, and in this case, it's not the case. And another fun thing is the author decided to create a registry key with non-ASCII characters. It sounds like stupid stuff, but for example, regedit crash when you try to read the registry key. It doesn't crash, you have an error message, but you cannot see the registry because Microsoft does not support non-ASCII characters for regedit. And I'm not kidding, but a lot of other tools have trouble with registry key in non-ASCII characters. And to be honest, we had the problem before I found the case and we patched it.
Yeah, we have patched the code to decode Unicode characters directly. So because in your registry we have, I don't remember, but you have 3 or 4 different formats to encoding data. So it's a bit tricky.
For example, if you look, it's a current version run, so it's a key to run automatically during Windows boot. And the value of the key is 101. So typically, even today, if you create a key with this value, the key name, regedit have trouble to read it. And so you have auto-hunt, and after you have these tricks that allow, I lost my mouse, that allow to load the content of this registry key and execute it. And this registry key is there. So basically, here I got a JavaScript loader, and here I've got the content of the JavaScript. And thanks to these 2 registry keys, the malware is able to be executed at every reboot of the machine without creating any file. So in this case, I cut the output, but this one is huge. It's, I don't know, it's 3 or 4 pages on my screen. So if you make a cut of the CSV, you can see a huge block of data you cannot understand. So it's basically something not really normal. And after you can easily decode it extra. It's not the most interesting part. So, we spoke about rootkit, I spoke about rootkit, I spoke about classic remote administration tool. And in this case, it's a bootkit, publicly mentioned by Kaspersky a few days ago, I think. And it's not really malware itself, from my point of view. It's a tool that allows you to install a malware thanks to bootkit mechanism. So basically, you've got hd-root. In argument, you put the executable you want to execute at the boot of the machine. And hd-root put everything in the good place to be able to start this bad file. So hd-root alone cannot do anything.
It's a framework to make a bootkit.
Yeah, exactly. And the fun thing is the sample I found. It's netstat from Microsoft. If you execute the binary without any option, you've got every option of netstat. You can use the option like a normal netstat, but you have magic option not documented, and this option are the framework. So it's interesting. So in this case, the bootkit modifies the MBR to be able to execute the bad stuff. And on our collector, we collect the bootloader on a file called bootloaderassemblycode.exe. And on one file, the .raw, you have the raw data, and the .txt file, you have the assembly code. And just for information, on the left, you have a normal MBR. So it starts by a lot of move instruction. And on the right, you have the MBR after the infection. So you've got move, a jump, move. So basically, the malware modify the beginning of the MBR to jump on its own code, do bad stuff, and go back to the normal execution flow. So typically, thanks to this artifact, you can guess that something goes wrong because you don't have jump at the beginning of the MBR like that. So it's a good indicator of compromise. If you are interested by this case, on our GitHub, we have a project called MISC or Miscellaneous, I don't know, and I put the source code of tools to detect this specific malware.
And to collect the MBR on a live system, we open the old disk on row, directly in row. We read byte by byte I don't remember. I think it's 520 bytes at the beginning of the disk is the MBR. We decoded the MBR. We catch the boot assembly code, and with this term, we transform hexadecimal mnemonic in assembly code to have human comprehension directly of the boot code of the system.
Yeah, because typically if you read Kaspersky article, it's really fun because they don't show you assembly. You have simply hexadecimal, and they write in red, it's a jump. Maybe they are really, really good and they don't need interpretation, I don't know.
For Neo in Matrix, it's very easy, but a normal human, it's complicated.
Yeah, so for conclusion, we know, we are not stupid, not too much. We know that the collector is not perfect. Some artifacts are missing. We have some bugs sometimes, extra. But we use it in real life, on real incident and real case, and it works. He helps us. He allows us to find a compromise system. Basically, each time we read publication with new trick, or we work on case with new tricks, extra, we try to implement the feature on the tools. We decided to push it in open source, so it will be on GitHub in a few minutes. So feel free to use it. Just for information, you have the source code, the Python, and we will provide a precompiled binary. So you can use it without making binary from Python simply by double-clicking on it. So it will be open source, so feel free to open issue if you have issue. And if you have some requests, not too much exotic requests, but feel free to open it on GitHub. It's maintained because we saw every day a lot of library tools extra in open source not maintained. So sometimes since years, as we use it in real life, it's maintained, and it's more or less everything. We just want to thank the people, the member of the Sequoia cert, because they use it a lot. They had bug and we try to fix it extra. So we have real users and we have real pain.
Yeah, we are 4 people to develop this collector. So a great job.
I only criticism from my point of view. I don't develop on it. I say I want that. It doesn't work extra. So thanks for your attention. If you have questions, feel free. Or awkward silence is cool too.
Thanks for the presentation. Just a quick question on the first example you gave. It was a rootkit which was probably hiding files. How does your collector collect the files that are already hidden because the Windows API are already hooked? So
yeah, it's really fun because it's only by chance. Yeah.
Could you expand?
We are allowed to have chance. No, honestly, if you look at the os.walk Python module, in fact, visibly it doesn't really use the Windows API. Yeah, it's like that. So even, and in this case, the hook to hide stuff are in kernel mode. It's not simply injected in userland on specific process, so only this specific process are not allowed to see the file, extra. In this case, it's really in kernel, and the Python module works better than the Explorer.exe, for example. So it's really by chance.
So Python does not use the standard Windows APIs to list files?
No.
Okay. Okay. Thank you.
Anybody else?
Thank you. I'm wondering on a normal case, let's say a Windows computer that has been used for 1 year, how long does it take with the regular profile you're using to run fast IR?
Yeah. So it really depends on the default profile. On inside of the binary you download on GitHub, for example, you only have it's a fast profile. It goes really quickly. It's 1 minute. But for example, you don't have the file catcher, so you don't create the zip file that contain exe in Windows directory not signed by Microsoft. This feature is not by default. You can create your own profile and say, I want to have it. The default profile doesn't dump MFT, for example. So it takes sometimes. But on Windows 7, with a normal setup and few applications, extra, on virtual machine, so it's slower than a normal system, it took around 10 minutes in my case, with dump of MFT, MBR, file catcher on Windows directory, document settings directory, etc. And the collect is around 700 megabytes in this case. And I avoid program file, because if you add program file, it's gigabytes, because basically we dump everything because nothing is correctly signed.
And second question, if I may, what is the footprint of executing FastIR on the system? Like the file you create, is it on the system, and then what's the memory footprint? Because you
Yeah,
can
yeah,
different data
I
as
understand.
well.
So no, you typically something fun you can collect yourself. If you are located in a document setting and you pass document setting, our binary is not signed by Microsoft, obviously. So it's detected like potentially suspicious. So we are not invisible for the system. If you look at if we collect a memory dump, for example, if you look on memory dump, you've got our execution, extra, extra. So it's not, yeah, it's not like for policeman point of view. We don't, the system doesn't stay perfectly clean. We have our execution, we have our output. Even if you can put the output on a share, for example, so you have less trust.
It's no law enforcement compliant.
Yeah.
That is the question. Yeah. If we collect the different artifacts with the method, we collect the first. It's a more volatile artifact. If you, for example, if you make a dump, the first dump it's MFT because MFT is very movable. After it's memory, and after it's registry key. And we have an algorithm to schedule the different artifact collection to collect to the more volatile artifact to the less volatile artifact. So just if, for example, you have a malware attacked on memory, just on memory, without file, without, you can just dump the RAM. We use directly a WinPayMem driver to collect the RAM, but we developed the Python script to load directly the driver and communicate with it.
Is a very long register key always suspicious, or you can have very long register key non-suspicious?
Yeah, typically for startup, we register everything, every startup entry. But typically, for the startup specific case, we only dump well-known startup stuff, not uncommon extra. And basically, we don't have so many entry. We have many. It depends of the system.
Yeah.
But,
For example, the artifact like MRU. So it's the action by a user directly in the system, like open a document, close a document, save as a document. There are many entries here to drivers. The registry is keys to drivers is many. You have many things in this key, but in startup CSV, startup key or a prefetch. You have small entries in the. And
something we must keep in mind is we must not work on only one file, startup file, but see the global picture, I want to say. Because, for example, I had a case where the attackers overwrite a legitimate binary. So it's the Adobe icon tray. So it's basically useless. But the attackers overwrite this binary by a bad file. And if you look at startup, it's clean. It's exactly the same startup than usual. But if you look at injected DLL, you can see that this Adobe icon tray is loaded on every browser and Explorer and other stuff extra. So it's not a normal behavior for the Adobe icon tray to do that. So in this case, the startup is useless. I cannot guess something, deduce if you are scientist. But thanks to other file and other artifact, I'm able to have a more global picture and say, okay, it's not a bad persistent mechanism, but behind the binary is obviously not the good one.
Okay, any more questions? And while I'm coming up here, is there anybody in French intelligence that would also like to comment on the slide earlier? Raise your hand now.
Thanks for the talk. How do you deal with processes which you said you use WMI, Windows Instrumentation Tools, to check in if a process has loaded XDLL, YDLL? What do you do when the rootkit or the malware hooks and hides the DLLs?
Paul explained for the rootkit, it's you don't use process DLL CSV to detect. We use file catcher with different signature persistence because the rootkit must be stored on the system. But on userland, because we fast collector is executed in userland, is useless to try to detect an hidden process but you can dump. It's a bit strong, but you can dump RAM. So in RAM with volatility, you can detect hook or detect modification of SSTD by the rootkit. So you have different way to the picture. The big picture of the tool is to have a collection, to have a big collection of different kind persistent system or persistent for or drops on the system. So it's very, very large. So that's why we collect different artifacts, and we don't have the same evidence in the different artifacts. It depends by the malware. Two different rats has two different behavior. So that's why we collect generic. We have a generic collect and a policy collection of artifacts to collect more and more information.
Okay, but do you try to check with yes?
To reply to your question, say no, we don't see the injection if it's not a clean injection, I want to say.
Okay.
But in the other hand, we have the handle, and if the badly loaded library the process have an handle on it, you are able to see the library is not loaded, but the process has an handle on this specific library. So you can cross the output of several files to have suspicious, typically.
Okay, but fast IR collector isn't able to do it automatically.
No.
I mean, disassemble the
No.
function and check.
No, and for the moment, we want to split in two parts. In one hand, you have the collect, the forensic collect, more or less without any intelligence. And in the future, we want to create something to receive all the CSV and make smart stuff on it. But today, we are focused on collect, and Yara, it's a little bit intelligent. Yara is the exception. But basically, the purpose was to have a collect, and in the future, put all the CSV together, put on the magic stuff, and have output of weird stuff.
Yeah, you must have a human to read the CSV it's a picture.
Yeah, it's not magic, sorry.